Hi everyone, my name is Abe and today we're going to be talking about kinematics with an example. So let's get into the example and we'll work through it. A stone is thrown vertically upwards from the top of a 20-meter building at 10 meters per second. How long does it take to hit the ground? So kinematics involves displacement or position, or here I've got x of t. Also involves velocity or speed, v of t, and it involves acceleration, a of t, right? So basically these things are related via antidifferentiation and differentiation. So you know that velocity is the rate of change of displacement. So if you differentiate displacement, you get velocity. Similarly, acceleration is the rate of change of velocity. So if you differentiate velocity, you get acceleration. And of course, you can go the other way with anti-differentiation, and that's what our little diagram there is all about. So, knowing that, let's get into our little problem. So it goes, alright, we're throwing a stone vertically from the top of a building at some speed, and we just want to know how long it takes before this stone hits the ground. So what does this thing actually tell us? It tells us that at the very start, so at t equals 0, what do we know? We know that we're throwing the stone at 10 meters per second, so v equals 10. Note that this is positive 10 because we're throwing it upwards. What else do we know? We know that at t equals 0, we are at the top of a 20-meter tall building. X, which is displacement, is 20. So here I've decided to measure x from the ground. You don't necessarily have to do that, but that's what I've chosen. X equals 20. So let's walk through and see what this thing really gives us. One thing to add is that on all of these things where objects are flying through the air, the only thing working on them are gravity and air resistance. So in methods, thankfully, we don't take into account air resistance. We do, however, take into account gravity, and gravity looks like this usually, negative 9.8 meters per second squared. So meters per second squared is the unit for acceleration, and it's negative because obviously gravity pulls you downwards. So knowing that, then, we know that if we anti-differentiate that, we can get velocity against time, and if we do that again, we get position against time, and then if we have a formula for x of t, position or displacement, then we can solve for when x equals 0. And that's when the thing x equals 0 means displacement from the ground is 0, and we find t, and then we can find when our thing hits the ground. So that's the strategy. So let's start. Now if a equals negative 9.8, then v, if you just anti-differentiate that, you'll get negative 9.8t plus c, right? Now, do we have any clues on how to find this c constant? I think we do. We know that at t equals 0, v equals 10, right? We talked about that just then, because when we throw our little stone off the building, we're throwing at 10 meters per second. So that's really good. And so we know that at t equals 0, v equals 10. So v is negative 9.8t plus 10. Yeah? So if you put t equals 0 into that, v will come out as 10. Great. So now I'm interested in x, the position of this stone at any time. Now, we know that we can get x by integrating v. So let's do that. So if you want to integrate negative 9.8t, you're going to come out with negative 4.9 t squared plus 10t plus a constant, d. Alright, what do we know about d? we know that t equals 0. At t equals 0, x equals 20. Yeah? So plug that in. At t equals 0, x equals 20. So d is equal to 20. X equals negative 4.9 t squared plus 10t plus 20. Now this is pretty useful to us because this is a graph, or this is an equation plotting the position of the stone versus time. So all we need to do is put x equals 0 in here. Remember that we're measuring distances from the ground. So x equals 0 means the stone is on the ground. And solve. So with your calculators, you'll see that if you do 0 equals negative 4.9 t squared plus 10t plus 20, you're going to get two answers, one of which is positive, one of which is negative. And you know that the negative one is no good because t, time elapsed, time doesn't go backwards, time's positive. And so you'll come out with t equals 3.28 seconds. And that's how long that stone takes to hit the ground. So, nice simple example. There's another example coming up, but for now, I'll see you in the next video.